So as we covered, like so as we cover, as I mentioned last time, like we are types of functions. Okay. So out of that, first one is like user-defined functions. So that is anyway, like like whatever the functions we are manually writing are our as a developer, what we are designing to write. So that all we call user-defined. So simply whatever the functions day by day we are writing, that all we technically called as user-defined only. Okay. And coming to the predefined means, so the functions which are already available in the Python libraries, so which may called as inbuilt or user-defined functions, and we have three variations also. Like some functions directly we can use without importing anything, but some functions we need to we can use by importing the respective module into our program. And some of them even external libraries we call like pandas, numpy, we need to install and we need to use it. Okay, based on the scope of the library we can use it. Okay, like example, if you simple example I'm taking, there is a name is there. Okay, now you want to convert them into uppercase letter. Let's take example, simply you can write name dot upper, that's it. You don't require to import anything, you don't require to install anything, because whatever the string functions we commonly use, that is already there in the Python install library itself. We don't require to install externally any other third party libraries. Okay, so this is what we called inbuilt functions, which are inbuilt available with the Python. Okay, like example, string functions or our traditional console functions like input and print. So we have some sort of functions like even operations with respect to variables. Okay, so like as I mentioned, right, typecasting, int of, float of. So these all functions are inbuilt available in the Python itself, so we can directly use them. Okay, and second category is it is available in the Python, but not directly in the Python library. It is a additional modules or additional libraries. So that's why we don't require to install additionally or separately, but we need to import them. For example, best example, math. Okay. So if you want to use the math library in your application, you need to import it first, like import math, and then you can write like, for example, print math dot, let's take row, but not row, seal. Okay, let's take seal. Yeah, sorry. Yeah, seal. Let's take 3.45. So something like this. Okay, so these libraries are available in Python itself, but you need to import, because this one not directly in the respective folder. It will be separate module. As a separate module we have, like example, time module or date module. Okay, so these are all we need to import it. Like example, if you want to slow down the system or slow down the execution, we can use sleep method. Okay, likewise. So first category, you can use directly inbuilt functions without importing anything. But second category, you need to import it before using that. Okay. And third category, third type, you need to install it. So it is not available first of all with the Python. These are we call external libraries or third party libraries. You need to install in your mission, then you can use it. Example, pandas. So if you want to use the pandas in your mission, you have to install them first. So install pandas. Okay, and then after this you need to import the pandas, import pandas, and then we have to use it. Like example, if you want to do the data frame or anything, let's take example, df equal to pd dot data frame, example I'm telling. Okay, so likewise, if you want to use this pandas library like numpy library or selenium or django, so these are all we call external libraries. That means it is not coming along with the Python, so we have to install them externally in the Python. For that we need to use pip install, or we can use in the Python also, we can install them. Okay, so this is how the installation, I mean the inbuilt functions we can use. So first one directly we can use, second one we can import the respective module and then we can use it, and third one we have to install and then we can import and use it. So these are the three types of inbuilt functions which are available in the Python. Okay, so in as per our requirement, whichever we are commonly using, we can use the respective approach. Any doubt as of now? Okay, fine. So now we have another type of function. So first one user defined and second one built-in or predefined. And the next category we have recursive functions. Okay. So recursive means if any function called by itself, let's take example def fn, okay, and within that also if you are calling fn only, that means if the function called by itself, okay, we called it as a recursive function. Recursive means it's indirectly a loop, a kind of loop will create. So always remember recursive functions we can use alternative to the your iterative functions or iterations, like example traditional for loop and while loop we generally use it, right, for iterations. So instead of that, you can use the recursion functions also. But for smaller and regular logic, we may go with the iterator tools like for loop and while loop. But if it is huge loops required, I mean the huge recursion required, whose iteration required, we can go with recursive functions. Like example, when you are dealing with the graphs or trees like binary search tree or BFS, DFS algorithm, such kind of trees and mostly trees and graphs, and also when you are doing the binary search, okay, so these all places we can use the recursive functions basically. So if any function called by itself we call recursive function, it is internally having the two conditions. One is general condition, another one exit condition. General condition means that will help you to repeat the logic, and exit condition means that will help you to stop the function. Okay, so we will take a simple example for this. I want to find the factorial of given value. Okay, so for factorial, I will show you how to do with using recursion. Okay, let's consider. Okay, I'm defining a function. So definition factorial recursion, and we will take the input n. So first, as you know, if n less than 0, okay, n less than 0, we can't perform the what we called factorial. So that's why I'm stopping the execution by returning the -1. So -1 is indicating there is no factorial. Else if n equal to 0. So as we know, 0 factorial can't be calculated, but it will be straight away we have to return the 1. So this is what we call exit condition, the factorial. So whenever the n value becomes 0, we need to stop the execution and we need to return the 1. Okay. And remember factorial definition as we know already. Okay. So if you define n factorial, so generally how it will be n into n minus 1 factorial. Okay. If you go for n minus 1 factorial, n into n minus 1, n minus 2 factorial. That means every time when you are calculating the factorial, that number into that number minus 1, again we have to do the factorial. So that is what I'm doing here. Else case, if it is more than 1, return n into means given value into n minus 1. We have to write the factorial. But instead of this symbol only, we are using a function name called factor. Okay. So here I'm writing factor of n minus 1. See now what happened? Within this function, I am calling again with the same name. So if you see, we are calling the factor within the factor only. So that's why we called this way of writing or this concept only recursive function. So here the else one is the general condition. That means it will repeat your same function until the value either it might be 0 or it might be less than 0. So in these two cases only this function will terminate. Otherwise this function will keep on call and it will keep on calculate the value. Let's take example 5 factorial means first it will come the n value 5. So now 5 into 5 minus 1 factorial means 5 into 4 factorial. Now again go back to the function. So now 4 factorial. 4 into 3 factorial. Now it will go to the 3. Likewise, it will go to the till the 0. Now when it will the n become 0, now instead of calling the factor of 0, it will return the 1. So that the entire loop will break now and it will calculate the 1 into 2 into 3 into 4 into 5 and it gives the 120. So that is how the recursion will happen. So the calling of the function within the function will execute. Okay. And now if I'm calling print fact r of, let's take I'm giving 5, and similarly I'm using print fact r of, let's take 0. Okay, now if I'm executing this program, you will get the output all 120 and 1. See that. And the same program even you can run through iteration also, means using for loop also. Like example, definition, fact, iteration of n, assume that. So now the same logic, okay, here the first two conditions will be same, but the third condition else part will be, instead of a recursion function, you can use the for loop also. Like example, f is equal to 1, okay, and now for I in range of, as you know, 5 factorial means 5 into 4 into 3 into 2 into 1. So n to till the 1. So that is indicating by 0, and every time it has to decrement by -1. For 5 into 4 into 3 into 2 into 1. So that is nothing but f equal to f into I. And final, after this loop, I want the final output, that is f. Okay. And now if you run this output, it also will give the same. Let's take fact instead of factor, fact I, and again I'm giving 5 only. So now both the functions will give you the 120 only. You see that. But the approach will be different. So first approach will be factorial by recursion, and second approach will be factorial by iteration. So but both are using repetition of the logic in different approaches. Okay, so any doubt till this point? So this is all about recursion functions. Okay, so the last one, the last type is here lambda functions. Okay, so lambda function means we called it is a inline function, or a function which will execute the code in single line. Okay, so basically lambda function will help you to run the entire expression into single line. So that's why in Python lambda functions are also, we call these are lambda expressions. Okay, so the syntax will be, we use lambda followed by arguments and followed by expression. Okay, so this is how we will use in the lambda concept. It's a one line code. Instead of writing def followed by function name and tab space, giving all that to code, instead of that you can write in a single line. So when we use this one mostly means when you have only one line of code. Example, I want to do the sum of the two numbers. So generally how we will write def sum, okay, a comma b colon, and after that maybe you can write c equal to a plus b, and then finally return c, right? General way of writing this is the, but instead of that the same function you can write lambda a comma b colon a plus b. So this is the way you can write simply the same function. Now this also will be give the same output as like this one. So likewise, if your logic does not contains much conditional looping statements or much connection to external libraries, it is having very limited expression, I mean that code, then we can use the lambda function instead of regular functions. Okay, so this is the major advantage. Okay, and one of the example I will give you with the lambda, so you can understand easily. Let's take example. There is a what do you call list of values. Okay, I want to do the filter the only even numbers, and I want to find the sum of them. Okay, so let's take example. Okay, so there is a list called some random numbers 1 comma 2 comma 3 comma 4 comma 5, assume that. Okay, now what I want to do, from this I want to filter the only even numbers and I want to find the sum. So generally traditional, if you want to do, okay, s is equal to 0 for x in li, and here you can write s is equal, sorry, if x percentile to equal to 0, s is equal to s plus x, and finally print the sum, print s. So this is the way, this is a very traditional approach of writing the, finding the data based on the conditions. This is the value, that is nothing but 6 plus 4 plus 2. Okay, now the same output even you can achieve using the lambda expressions also, instead of this entire logic. Okay, how we will do, you see, let's take s is equal to, okay, sum of, now we have an inbuilt function called there is a function called map. So map function will iterate each value based on, sorry, here we want to only even numbers, sorry, filter. Okay, filter will filter the data based on the condition. So what is the condition here? Even number, right? So simply you can write la lambda, input will be x, condition will be x percentile to equal to 0, comma, your actual list, L. Now you can print this as, you will get the output called same output. You see that. Same total you will get, see that. So instead of this much lines of code, I mean to say, like at least in this example, you written at least 4 lines of code to get the output. But instead of 4 lines, see, simply we written in the entire code in the single line. So this is how the lambda functions will help you to reduce the code when you have the only mathematical operations. I can say that when you have the mathematical expressions, it might help you to reduce that code into the single lines. Okay, that is a major advantage of the lambda functions in our regular programming. Okay. So this is about lambda functions in Python. Any doubt as of now? Okay, fine. So on top of it, there is another concept, simple concept we have is called decorator. Okay. So what do you mean by decorators are means? A decorator will help you to modify the existing functionality or function code without altering the internal code. I mean to say, there is already some function in the your program. Okay. You written some lines of code and it is executing well and as expected. Now after few days, there is a requirement to modify some, maybe before after the function you want to add some log or some time caption, something, some extra 1 or 2 lines you want to add it. Now instead of changing the actual code what we already committed, you can add a simple additional decorator for that to change the behavior internally. So that is how the decorator will help in the Python. So decorators will help you to modify the functionality without touching any internal code. Just external will write the modification and we'll tag that into actual function. That is the way how you will do that. So generally in Python, remember, whenever you are writing something followed by at the rate, so at the rate followed by if you write something, we called it is a decorator in Python. Okay. So whenever you write anything at the rate static method, at the rate anything if you write by at the rate, that is we call decorators. Okay. So now we'll see simple example for that. You will understood that also. Let's take very simple example I'm taking. I want to do the division of the two numbers. Okay. Therefore, division of a comma b. Okay. And here I'm writing print a by b. This is, as you know, very simple logic. Okay. A by b. And now I'm calling this function called div of one. Let's take 10 comma, sorry, 10 comma 2. And similarly, div, let's take 2 comma 0 I'm calling. Okay. Now I'm executing this program. See that what happened, you see. Yeah. Now you see, first one we got the output 10 by 2, that is 5.0. We got the output. Okay. But in the second case, we didn't get the output. We got instead of that error because division by 0. As you know, we cannot perform the something by 0 in mathematics. So that is not possible in the maths, right? So that's why instead of executing the program, we got an error called 0 division error. Okay. Now what is my ask is, now I already written this code and I committed, but after putting, I mean the deployed into the server, I realized that okay, this issue is not handled in the code. Now I want to handle it. So now, but I don't want to disturb this code because already it is deployed. Now I want to add additional enhancement for that. So for that only we use decorator. See now how I'm handling this without touching this code internally. So now def decorator, where it will take function as an argument always, and this decorator will call whenever you are executing this, it will execute the actual function, and whenever it is calling the decorator internally, what should execute or what should happen, that we will write in a separate function. Like example, I'm writing a wrapper function within that. Okay. And now what is our expectation now? If you remember, like here, whatever the inputs we are sending a comma b, the same inputs we have to write in the wrapper also, a comma b. Same, it should match always, remember. whatever the inputs, if it is empty, it should be empty. If you are passing some input, that should be passed in the wrapper. And now in the wrapper, you need to validate that condition. If b not equal to 0, okay, means if the denominator is not equal to 0, yes, we don't have any problem. This code should execute. So to call this code seamlessly without stopping that, we have to call the function argument whatever I written here. So it means that first, whenever you execute this program, it won't directly go to inside. First, it will go to the decorator, that to wrapper class. Now it is checking that whether b is 0 or not. If it is not equal to 0, then it will call the function. That means the pointer again come back to here. It will run this code. Else means it is equal to 0. I don't want to run the code, right? Simply I am throwing a message like b value cannot be 0. Got it? And finally, after completion of that, we need to close this function. So for that, you should return the wrapper function. Okay. After wrapper, you don't require to write any brackets. Yeah, that's it, Nana. So our code is done. And now this is the decorator should execute on top of this function, right? So for that, we have to give an indication called @deco. So decorator name. Okay. Now you can call this. See what happened. Where it is missing. Division and comma to function. Oh, sorry. So here, while calling the function, this function, as I mentioned, it will call this one, right? But is expecting two arguments. We are passing again empty. So same a comma b we have to pass here. Okay. And now run this. Yeah, see that? In first case, we got the actual output called 5.0. In second case, initially, if you remember, we got an error, right? But now you see instead of error, it's giving a message like b value cannot be 0. That means this code is handled properly now without touching internally in this function by using this concept called decorator. So decorator will help you to modify the behavior of the function without modify or writing the code in the function. We can append that into external function. Okay. So this is how the decorator will work in the Python, but it's one of the important concept in the Python programming. So any doubt as of now? Okay, if you don't have any questions, so tomorrow I will start the exception handling in Python. Okay, so by these functions completed, so just practice that, and tomorrow I will take the concept on exception, how to handle the exceptions in Python. Okay, so after that we may go for object oriented concepts. Okay, thank you. Thanks all.